Good morning. We are learning about ratio this week in maths, so I'm here to introduce you to it. We've done a little bit of work in Emerald class, some of us, as extension tasks, but I've never properly explained it. So hopefully today I will do that for you. So ratio. The idea for ratio is that we need to make our links to our understanding of fractions. But most importantly, we know our multiplication and division facts, so our times tables, to help us use ratio and see the relationship between the numbers that we're working with. So just a little heads up, that when we use ratio, it's so similar to fractions. So if you've got a sound understanding of fractions, ratio will come really easily. And if you don't, it's just another way of sectioning up and grouping different items and objects. So it says, obviously, ratio is the relation of one quantity to another. So how much of one thing there is in relation to another. So how many children there are to one teacher in a class. So 30 children to one teacher. The ratio is 30 to 1. Or if you were talking about the ratio of teachers to children, it would be 1 to 30. One teacher to 30 children. And proportion is more like a section or a part or a share of something. So it's normally a number of a group. So a proportion, how many within a group have yellow hair, for instance. How many within our class, how many people wear glasses. So it's looking at a sort of share of something. So if we start very simply looking at this particular concrete, or it's not concrete, it is pictorial representation of a ratio. So here we've got 3 boxes, the total of 3. And out of the 3 boxes, 2 of them are blue. So 2 out of 3, 2/3 are blue. And 1/3, 1 out of the 3, is green. Altogether there are 3 boxes. So as a fraction that would be 3 over 3, or 1 whole. 2 of them are blue, 1 of them is green. As a ratio, you would write the 2 of them being blue, with a colon, a dot over another dot. 2 are blue and 1 is green. So there are 2 blue boxes to every 1 green box. So these 2 numbers added together give us the denominator in the fraction. It says both these 2 numbers added together equal the total, like the numerator. It's more about how many there are in total. So there are 3 boxes in total, and out of them 2 are blue and 1 is green. So we can see that there are a total of 3. We can add the 2 and the 1 together to find that total. Let's have a look at a slightly different example. Or before we do that, let's have a look at how we can write it. So you would write, if it was the number of blue boxes to every green box, it would be 2 to 1. But if we were looking at the ratio of green to blue boxes, so how many green boxes are for every blue box, we would write it the other way around. So we'd write it 1 to 2. So for every green box, there are 2 blue boxes. So you need to make sure that when you're asked a question, you're writing it the correct way round. So here we go. Here's an example. What's the ratio of yellow boxes to purple boxes? So we need to remember that we're starting with the yellow. How many yellows are there? Then put the colon, and then how many purples are there? Simply we can see that there are 5 in total. There are 3 yellow boxes to 2 purple boxes. So we would write 3 colon 2. If the question were the other way around, so if it were the number of purple boxes to yellow, you would have to write 2 colon 3. And if we were to write this as a fraction, we would think about what the denominator would be. The denominator would be the total of items. There are 5, so that would be 2/5 are purple and 3/5 are yellow. Looking at ratios when we simplify. So when we simplify a fraction, we are trying to find the smallest common denominator. so the number that each of the numbers will fit into, to find the smallest number possible to write our fraction with. So just like with fractions, ratios can be simplified as well. Here's an example. There are 6 yellow boxes to 2 green boxes. So the ratio is 6 to 2. 6 yellow to every 2 green boxes. So we would write 6 colon 2. In order to simplify this, we need to find what is the highest common factor, or we could think about the lowest common denominator, to see which numbers both can be divided by. So we know that both 6 and 2 have a highest common factor of 2. We can divide, this means we can divide 2 by 2, and we can divide 6 by 2. So 2 divided by 2 would be 1, 6 divided by 2 would be 3. So a simplified ratio of yellow to green boxes, there are 6 yellow to 2 green. We simplify that by dividing both numbers by 2, and the simplified ratio is 3 to 1. So here's a ratio of 3 to 6. For every 3 yellow boxes, there are 6 blue boxes. Think about the highest common factor that these can be divided by. So very simply, we can divide both by 3. 3 divided by 3 is 1. 6 divided by 3 is 2. So for every 1 yellow box, there are 2 blue boxes. And we can actually see that pictorially. So there's 1 yellow box here, and there are 2 blue. 1 yellow, 2 blue. 1 yellow and 2 blue. So we can see evidence for that in both ways. So it's just confirming that we're right here. So for every 1 yellow square, there are 2 blues. So thinking about girls and boys in your class, so in Emerald class, there's actually an equal split. So we've got 15 girls and 15 boys. So as a ratio, we could write 15 to 15. Or we could write 1 to 1. So for every 1 boy, there is 1 girl. Think about that if you added me in. So I'm a girl. So now there are 15 boys and 16 girls. Think about how to write that as a ratio and if it can be simplified. Absolutely right. You cannot simplify it because of 16 and 15 not having a highest common factor, and because 15 and 16 would be the final answer, so that would be the ratio, 15 boys to 16 girls. Or if you're talking about girls to boys, it would be 16 girls to 15 boys. So last little challenge for you then. Andrew and Kate had a race to see who could drink the most cans of Cherryade in 1 hour. So for every can that Andrew drank, Kate drank 4 cans. In total, Andrew drank 3. So what's the ratio of cans that Andrew and Kate drank? And how many cans did each of them drink? So in order to work this out, we need to be thinking about how many Andrew drank and what number that would mean that Kate drank. So we know Andrew drank 3. So for every 1 he had, Kate had 4. So in order to go from 1 to 3, I multiply that number by 3. So for Kate, we need to multiply her number by 3 as well. We're doing the same thing on both sides. So Andrew had 3 cans. That's 3 times the amount that 3 times 1. So Kate had, for every 1 he has, Kate has 4. So we do 4 times 3, which we know is 12. So the ratio would be 3 to 12. So we've multiplied both sides by 3 because he had 3 helpings. He had 3 drinks. And so for every 1 he had, Kate had 4. So we've multiplied both sides by 3. And so in total, we've got, it would be 12 add 3. So the next question is then slightly a different way around. So 3 to 12, as you can see here. We didn't simplify it. We should have simplified it. So to find the highest common factor, we can divide 3 by 3 and 12 by 3. So the ratio, the simplified ratio is 1 to 4. So although the ratios are different, the proportions are the same. Now, the tasks that you're set for this week is to work through different ratio problems. The first one on Monday is this one here. So there's activity sheets, and I will explain all of them in a different video. Hopefully it will make sense to you. So I'll explain these sheets in a separate video.